Hi guys, this is organic nomenclature and we will be naming alkynes. Alkynes is a set of organic compound that has a functional group as a triple bond between two carbon atoms having the general formula CnH2n minus 2. Here we've got twice the number of hydrogen atoms as compared to the number of carbon atoms present minus 2 because of the presence of the triple bond. So the simplest alkyne would have two carbon atoms present and the name of this alkyne would be ethyne. The next compound in the series of alkynes would be having three carbon atoms. So this would be HC triple bond C and CH3, and this would be labeled as propyne. Now, if we introduce a carbon atom to propyne as a substitute group, it will not be considered a substitute group because the central carbon atom has already four bonds are present on it, so it cannot form a fifth bond. Whereas the substitutions are possible on the terminal carbon atom, and we already know if we introduce a substitute group on the terminal carbon atom, it only changes the name of the parent compound. So let's introduce a CH3 group on the left. So the compound would become CH3, C triple bond C and CH3. And the name of this compound having four carbon atoms would be butane. However, the position of the triple bond is between the second and the third carbon atom. So the name would not just be butane, it would be but2-ine. Now, introducing a CH3 group on the CH3 group on propyne would give us CH, no, not CH, because we start with only hydrogen in this case. So let us rewrite the formula here. We would start with hydrogen, then we would have a carbon, triple bonded to a carbon atom, single bonded to a CH2 group, and then to a CH3 group. So this way, now we've got four carbon atoms present. The numbering would definitely be from left to right, giving preference to the triple bond, which is the functional group. So 1, 2, 3, and 4. So the name of this compound would be butane. However, the position of the triple bond is on the first carbon atom, so the name of this compound becomes but1-ine. So, if we have butane as our parent compound, H, C, triple bond, C, then we've got CH and CH3. And if we introduce a methyl group here, CH3. Now we have introduction of a substitute group. However, preference would still be given to the functional group, which is the triple bond. So the numbering would be done from left to right. 1, 2, 3, and 4. And since we've got a methyl group present on the third carbon atom, the name of this compound would become 3-methyl but1-ine. So the preference is still given to the functional group, and the numbering of the substitute group is on the third position based on the functional group being present between the first and the second carbon atom. Uh, Another compound having a triple bond would be CH3, C, triple bond C, then we've got a CH, then we've got a CH, and lastly a CH3. So this compound would have 1, 2, 3, 4, 5, 6 carbon atoms. It would be hexyne. However, since we've got two substitute groups present, so if we introduce the substitute group as CH2 and CH3 on this position and a CH3 here. So we check for the length of the carbon chain starting from left and going down to the ethyl group 1, 2, 3, 4, 5, 6. So the name remains the same, so we let this be the substitute group. The numbering would be 1, 2, 3, 4, 5, and 6. So alphabetical preference would be given to the ethyl group. So the name of the compound becomes 4-ethyl 5-methyl hex 2-ine.